All right, so what I usually like to do is to just give you some announcement, reminders, and usually do some recap about the last lecture. But for today, since we didn't cover anything new from last time, so there's no recap. But we'll start doing it from next Tuesday. But let's just make some reminders, announcement, and then we'll move on to the review material. So last time we talked about the syllabus. You can find the recording and the notes already on the lecture site. Let me just say that once more. Just make sure you know where to find the stuff for your study. So if you go to the lecture site, you will see that the YouTube video has been posted, the recording from last time, and also the notes over here. And one thing, please note, for each lecture I'm going to talk about, for example, today, so there is the template page. You can click on that. So these are the blank pages which you can download beforehand, and also you can take notes together with me if you want to, right? I'll just make it available to you. You can feel free to use it if that's useful to you. And also, we got all the stuff over here, right? So that's a study material. You should really try catching up. Specifically, your top priority should be Lab 0 Part 1, right? The instruction is there. And click on that. On the top of the page, you got a submission deadline. Please make sure you don't miss that, right? It's stringent, strict. And we got a tutorial series required for you, and also the 2 PDFs that are also required for you to read. And you're going to need them for your programming test number 0. And just for your information, let's just see the calendar once more. Your programming test number 0 has been scheduled to happen on May 23rd. So if you think about we are here, and then in the coming 2 weeks, you're actually going to finish the review material, both the Lab 0 and also the lecture. And then the 3rd week, we're going to have your programming test number 0, just to make sure everybody's on the same page before we move on to the new material. And for you guys, benefits, again, it's optional. For next Friday, by the way, for this coming Friday, the 9th of May, the Lab 0 is pretty self-guided. So the TA will not be there, myself will not be there. Please, if you want to drop it at lab, go ahead and just complete your lab on your own. It should be very self-contained. However, starting from next week, the TAs and also myself will attend the labs. You can definitely come and talk to us. We'll be more than happy to help you. And one more thing that's also very important for next week, next Friday. All right, so for next Friday, I have something beneficial for you. You can definitely come and participate. For next Friday, the lab session will be divided into 2 halves. About the first half, 40 minutes, I'm going to give you guys a mock-up programming test number 0. It's not going to be counted for your grades, but it's just for you to get familiar with the lab test environments. For those of you who actually want to try and get used to the environments, feel free to come by. We should have enough seats for you. Okay, come by, and then we're going to boot out the machine in the first 40 minutes for each session, and then you can actually give it a try. And then in the remaining 40 minutes, myself and the TA will be there to answer your question about the lab, about the lecture material, etc. Right? That's for next Friday. But for tomorrow, this Friday, no TAs, no Jackie, okay, in the lab, just to let you know. And you want to make sure you actually complete your Lab 0 Part 1, right? Tutorial videos and also the PDF I just mentioned. And I think that's pretty much it. And Lab 0 Part 2 is going to be released on schedule next Monday. So just keep yourself reminded always about what's coming, right, for the course. So we'll try to definitely follow the calendar as much as possible. Okay. All right, guys, any question? Anything that's not clear to you, you want me to clarify before I start reviewing? Awesome. All right, let's now try to do some review stuff. So the plan would be for today, next week, Tuesday and Thursday, and possibly part of the Tuesday afterwards, we're going to do mostly review. But I will also clarify exactly what's going to be covered in Programming Test 0 next week as well. So you definitely get enough time to get prepared. So let's start a review. So the slides is already on the lecture site. I went up to here on Tuesday. So this page here, again, reminds you these are the 2 PDFs you must study in order to get a review done. And if you find any part of the PDF not clear to you, might be the time to talk to me to see if there's anything you might need clarification. And you will also be tested some material from there, or all of them, in the Programming Test 0. All right, just get yourself prepared for that. All right, the next slides, learning outcomes. So what are we going to review, really, just in principle? Object orientation, I want to just go from the more philosophical point of view, what object orientation really is. Because Java itself is definitely considered some procedural part, like if statements, loops, but what's really useful is about object orientation. How can you try to create classes, try to create different instances, and let them work together? That's really where object orientation comes from. That's something I want to do some conceptual sketch together with you today, right? Just to clarify that. And later on, when you get to the more advanced course, such as 3311, software design, we are going to take this further to see how you can create maybe tons of classes and see how they work together, right? So we'll give you some foundation in this course. And we're going to talk about the difference between templates and also instances. And you want to review the idea about attributes, constructors, and also methods, accessor or mutator, right? So these might be the terms you heard about before, but if you haven't remember the details, now will be the time to do it. And also how we can use the this keyword. So maybe not today, but maybe Tuesday, I will start talking about how you can use the this keyword. So there are basically some basic usage about this keyword just to disambiguate, to really avoid variable shadowing. That's something I'll talk about first, maybe on Tuesday. But the more advanced use of the this keyword is more to do with the reference aliasing, which I have to also show to you some example, right? Just remember this keyword is also very important for OOP. And then we're going to talk about instances, and the keyword you should know from Java is the new keyword, right? So that's really about allocating some memory space for storing the objects, and make sure you can know the syntax. And also the dot notation, right? Objects, dot, method, dot, method. You can have as many dots as necessary. So that's also something we've got to review. And reference aliasing, right? I'll talk about its definition maybe a little bit later. I do have some challenging example that we can go over together in the class. I may just try to maybe post it first over the weekend, so you can give it a try. Most likely we're going to go over the exercise next Thursday. So give it a try beforehand, before I walk it through together with you. And this is also very important. We're going to talk about reference type attributes. So you basically got primitive type or reference type. Primitive is like an integer, Boolean character. Pretty easy. But for reference type, that one's a little bit trickier. Even for reference type, you can subcategorize them into two cases. Either it's a single valued reference type or it's multi-value reference type. And for this course, we require you to use the primitive array in both the assignments and also the programming test. You are not allowed to use any Java library like an array list or a linked list because we want you to build everything from scratch, right? Anyway, you will see more requirements coming. I'll also talk about these two also in detail. Okay? Also, you learned a lot from the lab. And the final two topics will be about non-static versus static variables. That's also very standard use about creating global variables for your classes. I will talk about it most likely next Thursday. And the final topic here is something called helper method. That one is really for very good software engineering practice to really avoid duplicates in your code. And that is something I wouldn't spend time in the class. However, what I will do instead is to do some lab demo. So maybe on next Friday, I'm actually going to demo to you about how you can use helper methods. So you can come and then we can talk about helper method, right? May not be in the lecture, but during the lab session. That's more or less what we're going to review. But there will be quite a bit of slides I need to assign to you guys for self-reading, but very self-contained. I'm going to focus more in the class about visualization, about the core concept. That is really to make your visit to the class more worthwhile. And for today, I'm also going to maybe around the halfway through, we can try the iClicker for attendance check. It's only trial for this week. So starting from next Tuesday, we're going to do the real thing, randomly. Okay. All right, let's now talk about stuff. Okay. The first one to start with, just about separation of concern. It's, again, a very good software engineering principle. Whenever you want to develop a big project, you don't really want to put everything together under a single folder or single package. You want to separate them into different folders or different packages corresponding to different purposes. So it's called the separation concern. You're actually applying that in real life. In your computer desktop, hopefully you are not just putting everything at a flat level, right? You may have created some different folders, maybe one folder for 2030 and one folder for maybe other personal stuff, right? Just got different separation of concern. For our purpose, let me show to you. Okay, I'll just show to you very quickly some diagram here. You can also read the detail. In your coming labs and also programming test, you will have two packages mainly. One is so-called a model package. The other one is a JUnit test package. For console application, you might only see that for lab 0, just to connect a little bit to the first year. But you may want to forget about this particular package after lab 0, because we don't really recommend you try to do system.out print line to print something to the console. That's not the way to test your software. It wouldn't scale, okay? So what I would first do is, you want to think about this one here. You don't really want to use it too much for this course, right? This one is discouraged for this course, all right? But of course, I cannot stop you from using a system.out print line, but try to minimize it, right? So what we're going to focus on will be 2 packages. Briefly speaking, the model package is going to consist of all the logic of your implementation. The logic of your implementation. Basically, any classes you want to create to really solve a particular problem, you put them all in the model package. How many classes can you create? Unlimited. It could be 1, could be 2, could be 3, could be 4, or could be many. Okay? So the beauty about object orientation is you don't necessarily have to create just a single class solving every problem. That's the bad practice. That's what we so-called a Superman class. You don't want to have it. You want to somehow divide the labor into different classes, right? That's something you will see also in the coming labs. So for example, lab 1 and lab 2, you definitely don't have a single class. You got more than 2 classes to really worry about. That's really the exercise I designed to really help you understand how to have the classes and objects interacting with each other. All right, so you can go over just the list about like a different kind of ingredients you can put in the model. I'll let you go through that, okay? And the second package is so-called the testing package right here. JUnit tests over here. Apparently, all the JUnit assertions should really come over here. There's a clear separation concern over here. Why? Whenever you're trying to develop your logic, you put it here. But after you have after your development, is your development really correct? There's another purpose over here. So we want to verify the correctness in another package. That's why we have a separate one. So this one here has a single purpose, to verify the correctness of your implementation. Anything that has to do with the correctness verification, you put it in the JUnit test package. Anything that's to do with implementing the logic for solving your problem, you put it in the model, right? As clear as that. And for console application, please try to forget about it, okay, after lab 0, okay? You don't really need it. All right, so there's another thing I want to mention one more time. In order to really make the testing experience very rewarding, you have to make sure you study for the breakpoint and debugger. And debugger. You definitely cannot assume whatever you write in the model package is going to be correct by default. No way. All right? So you have to make sure you know how to use the breakpoint debugger. So if you run into any assertion failure, you will know how to solve them. You'll know how to fix them, identify the errors, things like that. Right? So breakpoint debugger, I definitely covered that in lab 0. But if you want to dive a little bit deeper, you can go to the optional materials that kind of reference to you. You can go there too. All right, separation of concern. And you guys can look at this slide as well. That's pretty much what I have just said. All right. And it is so important to understand about classes and objects. We'll get there today as well. And then, okay, that's good. All right, so this is the philosophical clarification I was just talking about. I think this is really important, right? It's really important for you to understand why are we using object orientation in the first place? Why are we not just stuck with C, which is very efficient, no doubt about it. C, arguably, is a more efficient language than Java. However, when you try to program some real-life application, you may actually prefer to really program in a large, meaning that you want to be very clear about what's the responsibility for different parties, so you can model it into different classes. This is not easy to be done just by using the syntax of C. C is meant to be just like for embedded system, but if you try to program maybe for web application, or maybe you're trying to program for maybe mobile app, object orientation will be much more useful. So it really depends on what your potential use is. Okay. So let's talk about this process over here. And the diagram I'm going to show to you, you can also download it if you wish. You can see the under over here, here on the lecture site. This is a diagram I'm going to go over with you. Right? So there are 3 phases over here. Let's clarify what they are very soon. Let's go over a little bit slides, and then I'll switch to iPad to show you in detail how it is supposed to be understood. All right, so that's the diagram. I'm going to zoom in just one moment. And there is some optional tutorial video just to show you a little bit more basic about the different stages. But I'm going to summarize in the lecture. So if you find the need to dive a little bit deeper, you can feel free, but it's not required. Okay, so there are 3 stages. We try to observe, and then we try to model, and also we try to execute. So these are the 3 stages. For this course, we're going to focus more on the model and execute. The observe part is more about to observe what's really happening in the real world and think about what's really the problem you're trying to solve. And then you want to turn that into something that's executable. That's something that's in a particular programming language. But in this course, typically you will be given very explicit hints about what classes and methods you have to create. We don't really give you that practice over here to see by observing what's really happening in the real world, you're going to create the Java classes accordingly. That one is more to do with maybe 4312, maybe requirements engineering or software design course. It's kind of beyond the scope. But I'll just mention that just for completeness today. Okay. Let's now take a look at some example here, right? Let's talk about observe, first of all. Okay. The first stage is about observe. Observe is, let's say I'm trying to develop some very simple application about persons. So I will observe there may be a person called Jim, right here. And there is another person maybe called Jonathan. I'm going to somehow observe the characteristic of these 2 persons and then try to work out maybe there's something they share in common. Maybe there's something they will exhibit as different. And then based on these observations, I will try to turn them into Java classes and methods. So this kind of transformation process is so important, right? But of course, in this course, you wouldn't be required to really do this transformation process, but I'll just give you some idea. Okay, let's say you talk about 2 persons, right? So first of all, we talk about 2 persons. Okay, we got 2 persons, and then we call them also entities. Every single object you can observe in the physical world, we call it an entity. Of course, entities can be of different kinds. For example, if you look at Jim and Jonathan, apparently they are the entities of the same kind. But if I look at, for example, my bag, the chair, there might be different kinds of entities, right? Just different. Okay. So here, you may just want to think about Jim and Jonathan. They are simply different entities, but of the same kind. Different entities of the same kind. So we are just going to focus on a particular entity called persons. Somehow this person entity kind is going to be turned into a Java class, somehow. And then individual entities of the same kind, they'll be turned into objects, somehow. All right? But let's dive a little bit deeper. So we got Jim and we got Jonathan, and when you observe them, you will actually try to look at what do they share in common. Whatever they share in common, we call them the attributes. Right here, the attributes. And for our purpose, let's say each one of them has a weight, they have a height. Weights and also height. Jim, as a person, has certain weights and also has certain heights. Also, for Jonathan, who is also a person, we can definitely be sure he has a weight and he has a height. However, I want to mention something right away. Even though entities of the same kind, they have the same set of attributes, like weight and height, the values for those attributes may be different between entities. I'm going to write down the principle for you. So entities of the same kind share the same set of attributes. I'll write down the principle first, and I'll give you the example. Okay? And principle number 2. Attribute values among entities may be different. Attributes, how about values of attributes? values of attributes among entities. Of course, we talk about entities of the same kind. May have different values. Right, so these two are really capture the essence of object orientation. But let's see some example right away. For example, entities of the same kind. We got Jonathan, also we got Jim. They share the same set of attributes. For example, they share weights, and also they share the heights. Okay, and then what about the value of the attributes? Over here, they might be different. For example, if I say if you look at that, for example, you can see Jim here is taller than Jonathan. So the height value is different, right? That one, just one example. So here you can say Jim dot height different from Jonathan dot height. So notice that when we talk about attributes versus values of attribute, they're different concept over here, right? Just make sure you got this distinction here. All right, so that's good. And then once you have somehow created the entities, we can now do several things. We can either try to change their attributes. For example, you might say Jim dot change their heights. Maybe they grow taller, maybe they grow heavier, right? That's I'll just give one example here. So changes could be something like grow taller. That'll be just one example. And also you can inquire about their information. So inquiries could be something like get heights. So as you study Java basics, you see whatever changes you can make to the entities, there should be some method that returns void. They are so-called mutator method. Right? That's something you will see when you review the slides. Okay? I'll just mention that verbally. And anything that's just to inquire about the information for your entities, for example, Jim.weights or Jonathan.weights, they will simply return some value back to you without changing the value of attributes. Okay? So these are just different things you can do on the entities. And finally, once you observe about the attributes, what possible changes, what possible inquiries you can make about the entities, you can define the template accordingly. Okay? So in this case, we want to declare a template called person. And the person template can now be instantiated into person like Jim or person like Jonathan. Okay? So these are the various ingredients for your observation. Right? And this, of course, is like an ongoing exercise you will have to do in real life. You don't necessarily be able to observe very accurately about all the entities at one go. So it's really like a feedback process between you and possibly your customer to see if they're satisfied with your observation. Things like that. Okay. All right, so what we have done was we have observed the entities for Jim and Jonathan here, right? So that's observe. There might be other kinds of entities which you can also observe. Okay, this will be the observe. You can also try to observe other different entities. For example, if you look at, we got different points on the two-dimensional plane. It could be x coordinates and also y coordinates. It's just another set of observation, right? Just different entities. But what we have just done is just about persons. You can try to do exercise to observe entities of kind point. It's different, all right? All right, so that's about observation. Okay, so the conclusion from our observation is we want to have a template called person. And the person template is going to be turned into a Java class right here. Okay, so that's very important. So you can think about the person template over here is going to be turned into a class called person right here. Java. Okay, so class is a template. And then for each of the attributes over here, they are the attributes, right? You can think about the attribute that we have over here. So we got the name, for example, Jim or Jonathan, and the weights, and also the heights. So these are the common characteristic among all the entities of type person. Of course, individual persons may have different name, they may have different weights, and they may have different heights for their values. Okay. And I'll speak about the types over here a little bit more later. Okay. For now, just remember, every time you want to declare some attributes like a variable in the class, you have to give a type. I'll talk about it in just one moment. And this one here, just another template, right? You got a point template. Each point has x and y, meaning that if you want to characterize a point on the two-dimensional plane, you have to give the x, you have to give the y, both of them. You don't really give the weight and height to characterize a point, right? You got to give the relevance measures to characterize that particular kind of entities. So far we talk about observation, and then we turn the observation into Java class. And this Java class editing stage is what we call compilation stage. All right, that's another term you want to review. So in our case, we're going to use the Eclipse IDE for your labs and also for your programming test. So what we got is compilation time. Okay, compilation. Compilation time just happens when you are trying to edit your code in the Eclipse, the editor, right? You may want to type class person, you want to maybe try to rename some variable, etc. Right? Whatever you do on the Eclipse editor is called compilation. So this is the editing in Eclipse. Of course, it doesn't need to be Eclipse in general. It could be IntelliJ, or it could be Visual Studio, whatever coding editor you're using, right? And for compilation, of course, there are two possible outcomes. Either you don't have any compilation error, or you have some compilation error. Either way, okay? There are two outcomes. Either there's no compilation error, or there could be some compilation error. And I'll give you some typical kind. There might be some compilation error. One would be maybe syntax error. For example, you simply spell the keyword class wrong. Or maybe when you are trying to implement your method, you forgot to put semicolon at the end. That could be syntax error, right? Hopefully that wouldn't happen to you, because syntax error is really something you're supposed to get rid of already from the first year. And the second kind of error is something called type error. That will be something we have to see more example to appreciate, but I'll give you one example, okay? What's really a type error? I'll put it here. Type error simply means you're trying to manipulate the values in the variable in a way that's inconsistent. For example, when you're trying to do multiplication, you're only supposed to multiply two numbers. However, if you try to multiply a string by a number, it's considered as a type error. Okay? One example would be string S will be, for example, 23. Right? You can see that's in quote. You got another one, let's say integer I, 46. And now I'm trying to do integer j equals S times I. If you look at this fragment of code over here, there is no syntax error. You haven't spelled anything wrong. You have declared variables. You have tried to use the multiplication operator. Nothing wrong. However, the way you're trying to manipulate the multiplication operator is simply inconsistent. So you can see that this over here is a compilation error. So this one here is a type error. Okay, I'll try to move this one here a little bit so you don't really get too confused. All right, so type error. Specifically, you can see when you try to do multiplication, you're trying to multiply a string with an integer. Not possible. Okay, that's one example. So either a syntax error or a type error is going to give you compilation error. So this is something you definitely want to practice avoiding when you're doing the lab exercises. In the programming test, if you actually got compilation error, that simply means your program cannot be executed properly and you'll receive some penalty on the marks. You're supposed to submit something that's at least compilation error free. That's the minimum standard we are requiring for programming. Okay? You want to be a serious programmer. All right, so either you have no compilation error or you have some compilation error. All right, so that's about the modeling stage. The final stage is based on the template, you can create as many instances as you like from the same template. For example, we can create one instance that corresponds to Jim and one instance that corresponds to Jonathan. Okay, let's make some correspondence over here. You can think about the Jim over here. Oh, I meant to do this. Think about the Jim over here correspond to the real world Jim over here. And the Jonathan over here correspond to the real life Jonathan over here, right? So that's really the beauty and value about object orientation. We are turning whatever that we can observe tangibly in the real world into something that's in program. That's what really object orientation is. So we got Jim, we got Jonathan. You can see both of them. Let's look at a bit more detail. So the way I draw the boxes, I'll talk about them also in more systematic fashion. You can also see the rule also on the slides. In this course, as we get more and more deeper into the material, normally the best way for you to really understand and solve problems is by tracing the code. And in order for you to trace OO code, you will have to somehow visualize what the objects are involved. And this, to me, is really, according to my experience, this will be the best way for you to really draw the diagram. I'm going to do lots of diagram drawing throughout the course, so you don't need to worry. This is just one first exposure to it. So let's say for Jim here, it's a person, right? It's a template. So person here and the person here, the same template. And then they share the same attributes. Jim has name, weights, and heights. Jonathan also has name, weights, and heights, the same attributes. However, remember principle number 2. Individual entities of the same kind, they may have different attribute values. In this case, for example, you can see we have Jim versus Jonathan. We have 1.8. Well, they happen to be the same, but it could be different. For example, let's say I can change this one here. Rather than 1.8, I can change that into possibly 1.9. Right? Could be different. Okay. Okay. And then in the runtime, we can also have maybe entities of other kinds, just different objects. You can have as many objects as you like at the runtime. It's only bounded by the computer memory, which is pretty much, you can assume, to be unlimited. All right, so the last stage over here is about execute, which is a runtime objects. So what you really want to distinguish between is the compile time versus runtime over here, these two. Right, let me say a little bit more about the runtime. For the runtime, let me mention 3 points over here. Okay, I'll put it here. For the runtime, number 1. Okay, let me just put that because that space I want to leave for you as exercise. Okay, number 1. If you can go to the runtime, that means everything should compile. You should not have any compilation error. Everything compiles. And number 2, at the runtime, what can you do? You will normally do some object creations and method calls. That's something we'll see a lot throughout the course. You're going to create objects and also call methods. Create objects using the new keywords. And also call methods using the dot notation, which we'll also see. Right? Now I'm just trying to give you all the bullet points so you can review later. And number 3, which is also very important, let's say you have created so many objects and called so many methods, but something goes wrong. How can you know what exactly is wrong? That's called a debugging process. In order for you to really see what's really wrong, you have to use breakpoint and debugger for making sure your runtime is really run in a disciplined way. It's not really running into something that doesn't make real sense. Okay? So you're going to use the breakpoint and debugger. Breakpoints and debugger. All right, very quick recap. At the runtime, you basically have to make sure everything compiles from the previous stage for the modeling. And also, what you will do typically at the runtime will be creating new objects and also call methods using the dot notation. And then anything that goes wrong, or you want to somehow see what's going on at your particular runtime, you have to use a breakpoint and debugger to see. Right? And to see exactly how the model and execute components are put into practice, study lab 0. Right? I did the whole thing for you. All right? And of course, starting from lab number 1, you will get a chance to build many things from scratch, which is a good practice for you. Okay? So that's something you can look forward to. Okay? All right, guys, any question? Go. Yeah, okay, to you. Question first.
Talking about changes and inquiries.
Yeah.
Didn't get the changes, but I get the inquiries, the accessors and mutators.
Yeah, so I think for now, yeah, so changes simply means, let's say I'm given Jin, this particular entity. What does change really mean? I may have to change the height of Jin, maybe he grows taller. And when I talk about inquiry, it simply means given Jin, what's his current height without changing it? Yeah, so like a 2 distinction there. So once you study about accessor versus mutator, you will see the difference. Yeah. Question somewhere? I'll get to you. Oh, go ahead, that's fine.
Sorry. Can you please repeat the inquiries? Is that a method or?
Okay, good. Okay, let me make it even more explicit. I can see where the confusion might be. No problem. Okay, so when you talk about OO, object orientation. So we talk about basically, let's now do comparison thoroughly. We talk about templates. We talk about instances. And we talk about changes. And we talk about inquiries. You can think about these vocabulary are more for like a layman, like somebody who is not necessarily know about programming. Okay? That's kind of vocabulary you can communicate with them. But for you guys, you're more technical. So let's talk about OOP. What will be the correspondence? Templates, classes, Java classes. For instances, it will be objects. For changes, it's something called mutator or setters. Mutators or setters. For example, let's say in the person class, I can have some void method. Void is a keyword, right? Void simply means the method does not return anything. And then I can say void, maybe set the heights of a particular person. And that one there is going to take maybe a new heights. Double, and then the heights. I'll speak more about this particular thing that's inside the method. It's something called parameter, but I'll get there either today or next week. Okay? That's just one example. So the most important thing is whenever we talk about changes over here, it should really correspond to some void method in Java. Inquiries will be without changing the attribute values, we want to return what's the current status of the entities. So here I will just write. So accessors. You want access to the attribute values. Accessors or getters. An example could be, let's say I want to get the name of the person, Jim or Jonathan. So I can say string and then get name. Or I can say I want to get what's the BMI, body mass index, based on the weight and height. That can be another returning a different, like a double. Get BMI. Of course, in general, you may pass some information over here, but in this case, no, right? It's really up to your design. But in this case, you can see that we got something that's not void. Okay, I hope that answers your question, right? Just about the distinction. All right, any other questions? All right. Okay, so that's about the observe, model, execute process, and then let's move on a little bit. Okay. All right, so that's about this slide. So guys, please make sure you understand at a philosophical level. I think it's very important. That can lead you a very long way, not just this course, right? Just understand what OO really is about. And this OO process over here, of course, it's not applicable just to Java. If you go to any language that supports OO, Python supports OO, C++ supports OO, right, etc. Okay. All right. A little bit about OOP over here. This slide here, you can definitely also read over, just about entities, attribute, etc. Right? Nothing very tricky. I just want to show you one page over here. So this page also summarizes the ingredients for OOP. You can also take a look. I want to point out a particular interesting bit. It's about refactoring. Refactoring is something I would like to demo to you maybe in the lab when I talk about helper method. So whenever you talk about refactoring, that really means you want to only modify your code internally without any external user realizing it. I'll write it down. Refactoring simply means you want to modify the internal workings without any public or external users realizing it. For example, you may actually want to create some helper method. Create and also use some helper methods to remove code duplicates. For those of you who are not exactly sure what I'm talking about, that's okay. So that's something I'll demo to you. Also, it's on the slides. I'll do that next Friday. Okay. So refactoring is actually a very big topic, so we wouldn't really dive into detail, but I just want to show you some example about refactoring. So the main refactoring we'll do in this course, one of them is about creating helper method. Another one would be when we get to inheritance, you can somehow, by using some certain keyword in Java, you can refactor your classes by using inheritance. But that's for later, okay? Don't worry too much for now, all right? So take a look at the list over here. It just summarizes about many good things. One more thing, you can also see I mentioned about the dot notation, right? This is also very important, right? The dot notation. So let's say you create some object obj1, okay? Let's say. So you can say obj1 dot certain method. This might be as far as you will go in the first year. However, in the power about OOP is you can have as many dots as you like, as long as it compiles. In general, it could be obj1 dot m1 dot m2 dot m3, etc. It could be. It can go on forever. Exactly how to write the dot notation in a legal way that compiles is something we'll get into a little bit later. We'll see more and more examples. Okay. 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 Let me go a little bit further, and we shall take a quick break very soon. Okay. Let's just go over a little bit more. Okay. So that's about OOP. And then, so this one here, okay, from slide number 9 to 12, I'm just giving you a little bit more example. So this is like a given some informal description about what a problem is. You can think about this a little bit like an observation. Let's say I'm writing down my observation in some natural language. In this case, English. But it can be whatever natural language you're used to. Doesn't need to be English. So once you have got the informal text documenting your observation, you can somehow turn them into Java classes and Java attributes. So I'm going to do one example very quickly together with you. The other one you can take as exercise. So from slide number 9 to slide number 12, it's going to be about this exercise. You can also see solution on the slide as well. So let me just go until the end, and then I'll do one exercise together with you. So from slide number 9 to slide number 12. So this will be the exercise you can try. And if you look at the iPad notes over here, I'm going to go over example 1 together with you, okay, just to see. Okay, why don't you guys spend just one, okay, let me just make sure that's the one I want to talk about. Okay, why don't we take a look at example 2, okay, because that's just about person. That's something we just talked about. So let's just take advantage of that. And this one here is something you can try, okay? So let's say example 1 here will be exercise. And let's do example 2 quickly. Okay, why don't you just take 1 minute, read through this description over here very quickly. Okay, pretty easy to read, huh? I hope. So idea would be you have to usually to really observe and go from observe into modeling. You have to identify the critical nouns and also verbs. However, a common mistake is you're trying to turn every noun into some corresponding Java item. And also, you're trying to turn every verb into the corresponding Java item. You don't have to. You got to be selective. All right? So in this case, the noun I'm going to select will be something like this. Let's say I want to select some noun, person. But I'm not going to select being. It doesn't really make sense in my developments, right? It's just person. I don't need to choose human as well. Okay, we got attributes and behavior. That's fine. We're just describing it. And then somehow we got ages and growths. And also we got heights and weights. Somehow these kind of suggest to me how to characterize a person and how they might change, right? So here you can think about somehow we got age, and also we got heights, and also we got weights, right? So these are also obvious ones I can take as a candidates. And also, we also got some verbs. For example, ages here is also like a verb. You know, they can grow older, basically. And also, they can also grow on their heights and also weights. Right? So you can, this kind of analysis, we wouldn't do too much in this course, because typically you will be given the set of JUnit test cases telling you what classes you're supposed to create and what methods you're supposed to create. So one of the required PDF, I can kind of teach you how to, given JUnit test cases, how can you create the Java classes and methods accordingly. So that's why it's a required reading. Just make sure you read it before next week, so you wouldn't be so falling behind. All right, let's now, based on this kind of observation, let's now try to very quickly summarize what we have, right? So this is kind of the table we can summarize about different entities. We can have template, we got attributes, also different values, etc. Right? Let me just write it down for you quickly. So the template we have is person. And then we have some attributes. We have the weights, and also we have the heights. And at this stage, you may actually also want to think about what kind of value do you have for weights and heights. So here, for example, do you want to choose integer or do you want to choose double? Which one should you choose? And what's the justification for that? Anyone? Just let's do one justification. Go ahead.
Maybe integer, because
so let's. Sorry, go ahead.
our ages don't end in like decimal point, like double.
I agree, but okay, you're talking about, yes, I definitely forgot about to include age as well. You definitely don't say I'm 23.4 years old. You don't really say that usually, right? So I agree, age can be just integer. What about weight and height? Yeah, go ahead. Should be double. For example, you might say I'm 79.2 kilograms, things like that, right? Yeah, that's kind of the very easy design decision you have to make. So that's why we're going to choose the double over here for weights and heights. Okay, very good. And then we got some behavior. And the behavior over here could be either changes or can be inquiries, either way. Okay, so here we can have, let's say, double, get BMI. We may have, let's say, void, let's say, grow, taller, right? Something like that. Now, I'm basically talking about two things here. Let's look at these two. These two. Let me write them down first, and then we'll discuss them. How do I somehow get the instance-specific attribute values? For example, I might say I got Jim and Jonathan. I might say Jim dot get weight. And also Jim dot, Jonathan, I'll just say John. Dot get weight. Now, let's now review another term that's very important. First of all, let's agree. This method here and this method here, we are calling the same method. Agree? Get weight. However, are they going to give us the same result necessarily? Not necessarily, because the so-called context object over here, which can be either Jim or John, they are different entities. Right? So right here, we got Jim and John over here. We call them the context objects. So the idea about context objects are very critical when you do OOP. Even though you're calling the same method, but if the context objects are different, then you might get different values. Right? That's very important. Okay? And let's have another idea here. Let's say I want to have some behavior exhibited by the different entities. For example, let's say Jim and John, they might actually gain some weights at the same time, right? So I might say something like, let's say Jim dot gain weight. Let's say by 2 kilograms. And then we might also say John dot gain weight, 2 kilograms. And again, let's do the comparison. Here I got gain weights and also gain weights and passing the input 2. I'm still making the same method call. But are these two method calls are supposed to get the same effects? Not really, because somehow the gain weights over here by 2 is applied to the context object Jim. And here, the gain weights by 2 is applied to a different context object, so they may have different effects. And I'm going to illustrate a little bit further. Okay, just one moment. Again, you want to see the John and Jim over here. They are also context object, right? So context object here and also context object here. Okay, let me use a different page. Okay, I'm going to write them down to see exactly how things can be understood. So let's say we got 2 entities of type person. Okay. Of course, you might declare person, Jim, and you might instantiate a project. I'll talk about how to instantiate the objects a little bit later. And also, you got another person over here, John. Let's say we got 2 valid objects right here, okay? And then there might be something happening over here. Let's say Jim somehow, grow into maybe 64 kilograms, and John grows into 75 kilograms. Let's say somehow. So let's say at some point we try to say Jim dot get weight. And then we got John dot get weight. Okay, let's revisit the points. We are calling just the same method. However, the context object is different. So the return value may be different. Let's say, for example, let's say this one here gives us maybe 72. And this one here gives us, let's say, 85, let's say. Okay, so that's the principle number 1. Entities may have different attribute values. Let's say the next 2 lines. If I say Jim dot gain weight by 2, and then John dot gain weight by 2. And you can see that we got gain weights by 2, gain weights by 2, the same. However, these 2 methods, even though we're calling the same methods, they are actually applied to different context objects. So they're going to have different effects somehow. So this one here, you can see again, we got 2 different context objects, Jim versus Jonathan. Let's see exactly how the effect can be understood. What I will do is, I'm just going to copy and paste these 2 lines, the accessor. Just these 2. Yep, I'm going to put it here. Oh, just before I do that, let me move that a little bit to make more space. Right here. All right, let's now be more precise. Line number 1, line number 2, line number 3, line number 4, 5, and 6. Before we talk about the comparison 1 versus 2, we also talk about 3 versus 4. Let's now talk about 1 versus 5, and also 2 versus 6. First of all, let's talk about 1 versus 5. So if you think about this line here and this line over here, are these two lines going to return to the same value? I think it should, because I have the same context objects. I'm also calling the same method. I should get the same result. Would you agree? If you don't agree, why?
Because of the gain weight.
Which line?
Line 3.
Exactly right. All right. So guys, this point here explain another complication about OOP. Whenever, even though you're talking about the identical lines over here, but what happened in the middle determine if they execute in the same line is going to give you the same result. That's so important. All right. Not the same result, because in line number 3, you actually say Jim is going to gain weight from 72 to 74. He'll gain by 2. And similarly, if you actually compare, let me just say because of 3. And similarly, if you compare 2 here and also 6 over here, again, exactly the same line, same context objects, same method over here. However, different result because of which line? 3, 4. All right. Not the same result because of number 4. We haven't really spoken about how to visualize the object, so we may do that maybe a little bit later. But I think that these also illustrate about the tricky bits about OOP. So later on, when you actually get to the more complicated example, especially when aliasing comes into play, you have to know how to visualize objects and how to change things around whenever you got any method call. That's something we have to get you trained throughout the course. Okay? But these are just warm-up exercises. But if you're following so far, very good. Okay. All right, 8 questions so far. Good. Okay. So let's see. We may want to take a very short break. Just give me one moment. Okay. So this one here, just about declaring Java classes. That's all good. Okay. Why don't we take a very short break by taking trial attendance? Get your iClicker ready, please. All right. So let's now talk about review some very important topic, which is about Java data types. Okay. I'm just going to tell you the critical point on the slide very quickly. You can definitely read the details, but I'm also going to write some notes together with you to talk about different concepts over here. Okay, good. So when you review the slide, you should really review slide number 14 and 15 together. Okay, so there is the so-called primitive type, and it's just some numeration about integer, floating point, and character, and Boolean. So these are the possible primitive types. And as for the floating point, you can either use float or double, but for this course, always use double. We're not too worried about a capacity, just use double. And also for integer type, you can just use integer. We're not going to give you any example where you have to use a long to store a very long digits of integer. Right? Just integer will be okay. And primitive type and reference type. Okay? Before I get to the notes together with you, can you tell me what's the difference between primitive type versus reference type in Java in a single sentence? It could be a typical exam question there, right at the front, right? Explain the difference between a primitive type and reference type in Java. Give it a try.
So reference is an address?
Reference type is an address, I agree. Reference type simply denotes a value that's the address of some objects. I agree. What about primitive type? Yeah, primitive type is just like a simple value, basically, not really address, just simple value, 23, 46, or character C, etc. Pretty good. Okay, I'll get there in just one moment. Okay, we got primitive type, we got reference type, and one thing to notice, the string you have been using so often, maybe in the first year, string is not a primitive type. String, as you can see the naming convention, it is capitalized. It is a reference type. Meaning that whenever you're using a string variable, it actually stores the address of some string objects in the memory. Okay? And also, apart from that, any name that's referring to some existing class in your either the Java library or in your projects, they are the reference type. And let me repeat. Every time if you're referring to the name either of some existing class in the Java API library or some existing class in your projects, they are reference type. That's a simple definition. Okay? Or anything that's not primitive. Okay, just an example here. And when we talk about Java data type, the second slide is you have to think about what's the default value. If you simply declare the variable of certain data type without giving it any initial value, there will be some default value Java will do for you. Okay? For integer, it will just be 0. For any numbers, default value will just be 0. And for Boolean, it's going to be false. I wouldn't dive too much into it. There's a logical reason for actually why the default value should be false. But for now, just know it's actually false. And then for reference type, doesn't matter if it's string, person, point, scanner. For all the reference type, the default value is simply null. Because reference type is supposed to store address. If there's no address there, just null. No address. Okay. And since you may have null address for the reference type, if you're trying to invoke a method where the context object does not store any meaningful address, in that case, you get into something called null pointer exception. That's also something you have seen maybe in the first year. I'm also going to review that as well. Okay. So when you look at the slide number 14 and 15, so that's what you want to make sure you kind of go through the details, right? But let's now go back and let's now go over them in detail. Let's talk about principle. Okay. Number one, in Java, each variable must be declared with a type. Each variable must be. You have no choice. Must be declared with a type. And just for your knowledge, not necessarily every programming language is going to require you to declare the type for every variable. If the programming language requires you to declare the type, it's called statically typed language. On the other hand, for language like Python, it does not require you to declare type for variable. It's called dynamically typed language, just for your knowledge. Okay? So this is a characteristic of something called statically typed language, which Java is the case, C# is the case, for example. So this is called statically typed language. Static type programming language. On the other hand, you got something called dynamic type language. Programming language, for example, Python. Any scripting language is dynamically typed, like what you learned in 2031, for example, the Unix language. You don't need to declare a type. Okay. All right, that's principle number one. So for Java, let's just see example. How do you declare a type? So you may say one example would be integer I. Or I might say example, let's say person P. Right? Two examples, right? So let's dive into these two examples in detail. All right? Integer over here tells you, number one, is a primitive type. And the person over here is not primitive, so it's it's not primitive, it's a reference type. So it's a reference type. Number one. Number two, Whenever you see any type here, I want to refer you back to the slides. You want to make sure you really understand this definition here. Oh, sorry, right here. So that's actually the first bullet point. A type simply denotes a set of possible runtime values a variable can store. Let's apply this definition here. What does it really mean? When I declare I to be an integer, that means at a runtime, I can store anything as long as it's an integer. What about P? P can store any address as long as the address is the address for some objects of type person. Okay, I'll write it down. I here at runtime can store any integer value. On the other hand, if you look at the P over here, at a runtime, because P is of different type, P cannot store integer, P cannot store string. Can store any address of an object instantiated from the person class. Sounds a little bit verbose, but that's really the most complete explanation for that, right? So the consequence of declaring I to be of type integer versus the consequence of declaring variable P of type person, they are different, right? Some example. So let's say here, I might say, let's say I is assigned to 23, and later on, I might say I is assigned to, let's say, 46.7, right? Apparently, this is okay because 23 is an integer. On the other hand, this is not okay because 46.7 is not really an integer. I know what you're thinking. You might do some casting, but let's not worry about it. Okay? I'm just saying, if you simply write this one here, it's not okay because 46.7 is not compatible with integer. Okay? This one here is very, very interesting. Okay? Let's now talk about this one here. This one here, let's say there are three things you can do. But think about if I declare P, and I'm saying P is assigned to be some value. I'll put a question mark over here. By the end of the course, whenever you got a reference type, what can the right-hand side be for the question mark? Right? I think after the review lecture, you can understand the first two possibilities. But for the third one, I'm going to mention that right away, but you may want to review that again once we pass the reading week when we talk about inheritance. But I'll just mention them for completeness. You can do basically three possible things. Number one, you can say P is assigned to some new objects, person. This is saying I'm going to create some new person object in the memory and store its address into P. And I'll visualize this on Tuesday when we go for some example on Eclipse. Number two, I can declare maybe another person object, let's say. Person, and then let's say P2. And then equals something. And then I can say P is assigned to P2. This one here, let me save the explanation a little bit for next Tuesday. Okay? But this one is just reassigning the app references. This is where the aliasing is going to occur. I'll just mention the term aliasing. That's possibility number two. Possibility number three over here. Okay? Let's say I got some other class called C. C, just some class. Let's say C. And then I got maybe object equals something over here. And I will be able to say P is assigned to objects. This is more advanced, but I just want to mention that. This variable assignment will be allowed if C is declared to be a subclass of person. And that's exactly what we have to dive into for about 5 to 6 lectures for inheritance. I'm going to write it down for now, but it will make much more sense once we get to inheritance. So this one here is going to be valid if C is a subclass of person. All right, so I'm going to put a star over here. You don't have to worry about possibility number 3 for now at all. Okay, we'll get there in very much detail. There's a logical reasoning behind that we have to go over together. But for 1 and 2, that's something you got to make sure you understand. All right, so that's about principle number 1. And principle number 2. That's pretty much what I just mentioned, but I'll just say here. A declare type denotes the set of values that is allowed to be stored in that variable. And this is exactly what I just illustrated. For example, if you declare I to be integer, it can only store integer. If you declare P to be person, it can only store person object addresses in P. All right? That's really what principle number 2 is talking about. Okay? Question? All right, if no, let me just talk about 1 or 2 more things. We'll see. Okay. And another thing I want to talk about is here. Let's now talk about the visualization a little bit, okay, about primitive versus reference type. So if I got integer I here, and then versus if I got person P. So this, as we said, is primitive type. Primitive type. And this one here is reference type. Reference type. All right, pretty good. And let's see how we can visualize I and P a little bit differently. Okay, I think that will help when you try to trace your program. About I is primitive, it's a simple value, just a value. At runtime, I can store any integer value. And the way I like to visualize it is like a box. And then the box has a name called I. You can store whatever value you like. For example, you might say I initially is simply 23. I'm just going to store 23 here. Later on, if I say I is reassigned to 46, I'm just going to replace the value into 46. Right? Simple. On the other hand, what about this one here? This one here is a bit trickier, but I'm just trying to do a little bit just for today. So for P over here, by definition, at a runtime, P can store the reference or address. Something I want to mention also, again, for your knowledge. Usually when people talk about Java, we don't really say address because strictly speaking, what you will see, which I'll illustrate to you Eclipse, is not exactly like a memory address. It's really like a reference, like a pseudo-reference that Eclipse creates for you to see. When you really talk about real memory address, you can only see that in a programming language like a C, where you can do pointer arithmetic. Right? But it's okay. For this course, if you say address versus reference, we don't really distinguish between them. But strictly speaking, it should be just about reference. I'll revisit this point when I show you in the Eclipse. Of some person objects. Okay, so there are 2 visualizations that's possible. I'll show you both. And I can tell you, you can easily tell which one should be more recommended. Visualization number 1. Okay, so P here, by definition, is going to store the address of some person object in the memory. So let's say this is my computer memory. Somehow, I have allocated some memory space for storing some person. Let's say for Jin. Right? Let's say this block of memory contains the information for Jin. And that one there has a starting address, let's say 0x123, let's say. And P here does not store the entire object. It does not do it. You only store the starting address over here. Okay? So all we do is store 0, 6, 1, 2, 3. It's a very important point for you to realize at the hardware level, the P there does not store the entire objects because object in general can be arbitrarily complicated, which will take a lot of space. But for the reference variable, you only store the starting address. So that's visualization number 1. Visualization number 2. I'll finish that. Give me one moment. For visualization number 2, you will say P here is basically going to point to some block of memory over there, and that memory has the type person, the template name. And for that particular object, we can subdivide them into different attributes. I might get the weights, I might get the heights, and I got one, let's say 96.2 and then 180.5, right? You got visualization number 1, visualization number 2. They're both right. Now, which one would you choose? I would say number 1 is important to really understand more at the hardware level. But to solve problems in a more sophisticated manner, I would suggest we use number 2 when we actually solve the problem. That's something I will show you a lot. All right? Okay, again, for this Friday, there's no TA, no Jackie in the lab, but starting from next Friday, TA and myself will be there. All right, please review up to here, and then see you next time.